I think I am live now. Can anyone confirm if audio and everything looks fine before we get started? Hello? Hello, hello. Can anyone confirm if audio and everything looks fine? Hello? Yes, like I hope I don't have to shift to Windows. Like that's the only thing I am trying to do. Hello, like can anyone confirm first if audio and everything is fine even before we get started? Okay, so then I will probably start from the this problem only. Okay, like I haven't really read the first three easy problems to be honest. Most of the contest, like I was in among, I kept solving these problems only. So let's just read and try to solve it here. It says Rahul has a 5-page assignment due in 60 minutes. He can write one page in X minutes. Determine if Rahul can complete this assignment within the given time constraint. X is between this to this. So like what we can see is like Rahul can complete Rahul can complete one page in X minutes. So like to complete 5 assignment, he will need 5x time. So like, and he has time limit left is less than equal to 60. So this implies if x is less than equal to 12, then Rahul will be able to complete the assignment. Otherwise, Rahul will not be able to complete the assignment. And like that's the only condition you have to check. And like I will probably check one of the submission as well. Yes, 5 into n should be less than equal to 60 print yes, otherwise print no. And essentially that's the solution. Penalty shootout next problem. It says in a football match, a penalty shootout is used to determine the winner if the score is tied after regulation and extra time. Each team takes turns attempting 5 penalty shootouts. Team A has scored X goal in 3 turns, while Team B has scored Y goals in 4 turns. Determine it is possible for penalty shootout to end with equal score after both teams have taken all the 5 penalties. X goal like and Y goal, right? One second, like why does scroll does not work? So like let's see, like one of the team has X score right now and another team has Y score right now. This team has 2 more turns and this team has only 1 more turn. So like what are the choices? Like if currently X equal to Y, then like both the teams can miss both the shots and they would be good here. Another choice is like like the possible score for the first team, it would be like the possible score for the first team is x plus 1, x plus 2, and the possible score for the second team is y and y plus 1. So like we can check if this set like if any number here is common with any number here, and essentially that should be the solution here. So like, and like that is the only condition we need over here. Okay, dark background is here, and yeah, like that's the only condition we need here. But I will probably like you can probably try to simplify cases here, but that's wrong. For I, like a user has said for I equal to 0 to 1, for j equal to 0 to 1, if I plus 1 equal to j plus 1, like this is the updated score for the first person and this is the updated score for the second person, then it's possible is true. And if it's possible is to print yes, otherwise print no, and that's the solution over here. Okay, and like moving on to the next problem. It says chef loves pizza, chef loves house. Chef has a unique way of cutting round pizzas. He starts by cutting the pizza in half and then quarters, then eighths and so on. Always cutting through the center. Example is below 1, 2, 6, 1, 2, 6, 8, 10 and so on. Chef wants to cut pizza into x slices where x is even. Your task is to determine the number of pieces that will be smaller than the rest. Okay, 1 second. Like in case of 2, like it's half. In case of 14, like for example, in case Chef has 14 pieces right now, then like every time when he makes a cut, 2 new pieces are drawn over here. So here we have 2 pieces, 4, 6, 8, 10, 12, 14. So here you can see like there are 2 large sizes, like, and pretty much that was the idea here. Like, like so like you always have equal sizes pizza when x is a power of 2. This would be the case when you will have equal size pizzas. All pizzas would be of equal size. And for all the other cases, like what will happen is like, let's say right now you have, let's say 10 pizzas, or probably let's take 20. Then when you have 16 pieces, all the pieces would be equal. And when you have 32 pieces, all the size would be equal. And in between them, like when you from 16 you will move to 18, and then you will move to 20. This would be the first time when you will cut a piece into 2, and like here, like you will have 15 large pieces. No, like every time you cut here you will have 14 large pieces and 2 small pieces, because like whenever you make a cut, that piece takes 2 of the pieces there and puts them into 2 different smaller sizes. And when you have 20, like you would have 12 small large size and 4 small size. Or to put it the other way, like let's see like how does cutting takes place. On the first cut, you have 2 pieces equal sizes. Second time, you again have equal size. Now the next time when you make a cut, Next time when you make a cut, you have taken two large pieces and reduced them into small sizes. Now the next time you again took two pieces, reduce them into small size, and you can keep going here. And that is the main idea. Like find the smallest, find the power. If x is find power of 2 which is less than equal to x, and find power of 2 which is greater than equal to j. If 2 to the power I is equal to 2 to the power j, then all the pieces are of equal size. You should print 0 or x, whatever be the case. And otherwise, you know that you initially had 2 to the power I pieces. From them, otherwise, like what you are doing is you have 2 to the power I large size pizza. You take 2 pieces from here and make 4 pieces from there. And in the next cut, like the number of small size pieces becomes 8 and it becomes 2 to the power I minus 4 and so on. Like this is the story here. So 2 to the power I minus x minus 2 to the power I by 2. And like that would be the solution here. And I can probably look at one of the submissions here. If like seal floor, like a user has checked like if x is 2 to is some power of 2, print 0 directly. Otherwise, find the smallest power where x is 2 to the power I, and then yeah, like it's the 2 to the power I which is just less than this. Like you can essentially simplify this approach as well to like into 2 by 2. So this will become 2 to the power I minus x by 2 and so on. Essentially that is the idea. 1 second, like let me just check if like x was 2 to the power I less than, okay, yeah, like this 2 is also there, right? So like into 2, yeah. So basically a 2 to the power I which is just greater than that, and you can subtract it. Or to simplify the solution, find the power of x 2 which is greater than equal to x. And the answer is 2 to the power I minus x by 2. Any questions on this so far before we move to the next problem? Or any questions on the first set problem? Okay, you can ask doubt like what do you have, like probably like if there are any questions on the first set problem, I would try to explain them. Otherwise, I will move to D1 problems then. Okay, I will move to array removal then. It says you are given an array A of size n. Your task is to determine minimum number of elements that needs to be removed from the array A. such that bitwise OR of remaining elements is 2 to the power I x minus 1 for some x greater than equal to 0. Note that bitwise OR of an empty array is considered to be 0. So it says like we have a given array and an here. We can remove some of the numbers from here. We can remove some of the numbers from here. Like for example, let's say we have removed this number, and then we take bitwise OR of all the remaining numbers. And it says like this remaining bitwise OR should be a power of 2. Like basically 2 to the power x minus 1. Not power of 2, 2 to the power x minus 1. And the main idea is like, let's look at the highest number after. Like there would be some maximum number remaining, assuming that the final list has some 0 number. And this is how something like will look like here. Like so far I have explained the problem statement. Now my idea is like, let's say we have removed some numbers. And now let's look at the maximum element remaining over there. Like the maximum number will have some on bit, assuming that maximum is greater than 0. Like if everything is 0, that's fine. Then the idea is like, let's say this is the highest on bit. Then the final OR we want would be something like this. And like that is the main idea. Okay, like we keep removing, like if we sort the array, then like there would be some prefix for every prefix OR. Every prefix OR, if it's 2 to the power x minus 1, then you can do like answer equal to max of like basically remaining numbers you want to delete, minimum of whatever number we want to delete. And probably I can try to explain it again. Like I'm not sure like why just taking. The main idea is like you have some remaining numbers left. There would be some element maximum from it. And if we look at binary representation of max, it will have some starting bit 0, then some bits on. And if you look at any other number, AJ, AK, AL, then like every bit, all of these bits would be 0 for all the numbers. And like it never hurts to take all the remaining number, because bitwise OR can always increase from 0 to 1 only. Like if you take some extra number, your sum of the existing bit in the XOR can change from 0 to 1, but they can never change from 1 to 0. So it's a greedy idea that you just take everything less than whatever max you have taken over here. And like pretty much that was the solution I had. And then the idea was to fix the maximum value and see what is bitwise OR of all the numbers over there. And pick the one which deletes the minimum number of elements. So this was my code, like sort all the numbers, sort in increasing order, and keep taking prefix OR. Like this is how you can probably check. There are multiple ways to check if a number is 2 to the power x or not. We can first pre-compute all the powers of 2. Like, or let's say valid numbers. If current XOR is not present in valid, ignore it. Otherwise, like you can remove all the remaining numbers and see whatever remains over. And that was my solution for this problem. Any questions on this one? And yeah, n and n minus 1 is other way to check if a particular number is power of 2 or not. Like this is other way you can, using which you can check if a number is power of 2 or not. Like this value should be 0 for the power of 2. And that, yeah, like DP, I'm not sure like why we would like to use over here, because like once you realize the observation, then we don't really need a DP here. And like it will only give you some incorrect ideas. Okay, next problem I would probably move to. Next problem, if there are no more questions on array removal, I will move to the next problem. Okay, given a positive integer x, find the smallest positive integer y satisfying all the following conditions. Y must not be a prime number. Y should not be a perfect square. No factor of y other than x is less than x. Note that y might not fit 32 int, that's fine. So it says we are given some number x. We want to find smallest number y. Such that it should satisfy some of the condition. y should not be equal to some prime. Y should not be equal to some prime square, and all the factors of which are not equal to 1 should be greater than equal to x. And like these are the three conditions we need. Okay, and like the main idea is like, let's look at the sum. Let's say we have found some number z. Let's look at its prime factorization. P1 to the power n1, p to the power n2, p to the power n3, and so on. Like, let's, if we look at the prime factorization of y, some number z, this is how it would look like. And like the smallest prime factor apart, like 1 is definitely a factor here. One is definitely a factor here which we cannot remove it. And second smallest factor over here would be minimum element of P1, P2, and so on up to Pn. And because, and what we need is like, this value definitely must be equal to x. Like, if we look at any number z, like this would be their prime factorization. Like, looking at a prime factorization, and like now, if like the smallest factor here is 1, second smallest factor here would be the smallest prime factor, which is here. So which is min of x should be greater than equal to y. And now once we know that, like, we want like all the numbers greater than this, then the smallest number, like, so what we can do is like, we can find two prime numbers, p1 which is greater than equal to x, p2 which is greater than equal to x, p1 square, like the smallest prime number which is greater than equal to x, let's find two prime factors which are greater than equal to x. Then like the smallest number we need y, we can directly take this number. This should be our final y. Like, how to find like two prime numbers which are greater than x, smallest prime number which are greater than x, that can be, we can keep it for now. But any questions why if we find two prime factors which are greater than x, then that would be our solution. Like, we cannot take p1 square because we have been told not to take a perfect square there. And the idea is like, we can brute force for the next two numbers. Like, we can start a for loop from x equal to 1 to n. We can maintain a function is prime which returns true if a number is prime and false if a number is not prime. And as soon as we found two numbers, we can directly print their product. And to check a number is prime, we can start from 2. We can go up till square root of n. And like essentially that would be the idea. And like, this is probably the method using which you can take prime. Like, we cannot take p1 because we have been told y should not be a prime. So like, y should have a number other than just a prime number. We cannot take p1 square because we have been told p2 is not a perfect square. We cannot take just p2 because it's again the number. Like, to put it more generally, p1, p2, p1 square, p2 square. Generally, this is how the order of numbers greater than x would look like. There can be some cases where like these can probably be swapped, but otherwise like that's the order. Like my idea was to start a for loop with j equal to x, keep going, check if current number j is prime. If you just put it in the array, and like as soon as you array size becomes 2, you break it. And to check a number is prime or not, you loop from 2 up to square root of n and check if any number divides that number or not. And the question is like why this solution does not give us daily. Yes, time complexity is the important question Sanat asked here. So like the reason is like let's look at, there is something known as prime gap. Here it says, for example, if you look at all the numbers up to 89, maximum difference between any two prime numbers is 8. So for example, if you start a for loop from any number which is less than 10, and if you go from n plus 1 up to n plus 8, you will definitely find one prime number. And similarly, in our case, like we have been told that y is up to 10 to the power 9, x is up to 10 to the power 9. So like this is a prime number up to 10 to the power 9. Then like what we know is like the gap here is 288. So like among all the numbers from 1 to 10 to the power 9, the maximum possible gap between any two numbers is 288. So like if we just go from j to j less than equal to 500, like if you start from x and you go up to x plus let's say 600, you will definitely find two prime numbers there. So overall time complexity would be 600 into the time taken to check a number is prime or not, which is up to 10 to the power 9. So overall time complexity for our case here would be, we won't have more than, like we will find one prime number when we check at least 300 numbers. So this is the number of times we will have to check, and like this is our time complexity to check primes or not. Can't we take p1 cube? Yeah, you can definitely take p1 cube. That is one number which satisfies the requirement. So you can probably take minimum of p1 cube, p1 into p2. And what I know is like p1 cube would definitely be larger than p1 into p2. Like what I know is like p1 into p2 is definitely smaller than p1 cube. Like the smallest case would be like p1 is 2 and p2 is 3, and even for that case p1 square becomes 8. And like that is the idea. Any questions on number hunt before we move to the Xor problem? So like someone is asking why p2 cannot be, like p1 square cannot be less than. So I'm not sure like if there exists a theorem or not, but like there is a conjecture which says like there definitely exists a prime number between any two perfect squares. And like you definitely know like there would be a perfect square after P1, like, and P1, like there would definitely be a perfect square between P1 and P1 square, assuming that P1 is not equal to 2. Because whatever is the number which is just less than P1 square would definitely be greater than the idea, like. And essentially like other ways, like P1 and P2 are the two numbers. You can try out all the combinations you have and just take the minimum of all of them. And that should serve all the needs. Like for example, the other options you have is P1 cube, P1, P2. Like you just take the minimum of these two and you should be good. Okay, I will probably move to the next problem, sum of Xors. You are given a grid of size n cross m where each cell of the grid has value 0. Let Ri denote bitwise Xor of all the elements of ith row and Ci denotes bitwise Xor of all the elements of ith column. Ugliness of a grid is defined as sum of all the values of Ri plus sum of all the values of Ci. And we have to find this let f of k be the minimum possible this value we can get after setting the value of exactly k cell of this grid as 1. Find the value of f of I where I is from 1 to n into m. And like it is also given that n and m both are even numbers. So like it did took me quite a long time, and like in the end I brute force it to look at the patterns there. So first thing first, let's say k is odd. Then what we know is like if we look at count of, like if count Ri denote counts of numbers in the ith row. Count Ri is the count of number of rows in the ith cell. And if we take this sum, this will definitely be equal to k. Because if you take the number of cells which are 1 in each row, and because we want all the numbers, total k numbers to be 1, then this is definitely 1. And if k is odd, then my claim is like there would be at least one row with odd ones. Makes sense, right? I will probably share my code like how I went through it, but let's first look at like what should be the correct solution here. And because like there would be at least one row which has odd number, then the minimum value of Ri sum would be greater than equal to 1. Because Ri is 1 when there are odd ones in that row. Ri is 0 when there are even ones in a particular row. Because bitwise Xor of even times 1 is 0 and bitwise Xor of odd times 1 is 1. And similar argument for Ci. So what we know is like f of k would be greater than equal to 2 when k is odd. And like after that, I did not try proving it further. I just assumed that there would be one way to always get odds or whatever you want. The idea is like Like we would have one like this. Like if I keep filling it like this, then whenever you have filled k numbers, one of these row would have one Xor as 1 and other row would have Xor as 2. And like once I am completely done with this, I can start the next rows. If I keep filling it this row, then I am able to get f of k equal to 1 here. Whenever k is odd. Like the idea is pick 2 rows at a time, keep filling one cell at a time. So like any question so far, why when k is odd, f of k would always be 2. There are some questions in the chat, I think. Prime was taken care of, gap justifies it. And okay, someone has given a hint there. And how did you able to go in that specific? So that was my assumption. And now the next thing over here is like if we keep filling it this way, then you notice whenever k is multiple of 4, whenever k is multiple of 4, this algorithm will give us no. What I explained was whenever k is odd, and if I say count Ri as the number of ones in the ith row, then because I want to make k cells 1, count of all of these numbers would be equal to k. And if you have some numbers with sum equal to some numbers where the sum is odd, it is definitely the case that at least one of these numbers should be odd here, because sum of all the even numbers is even. And like that's how I came up with the observation that whenever this count Ri is, which is number of rows, and if k is odd, there would be at least one row where count Ri would be odd here. And for all the values where count are like a row which has odd number of ones, Xor of all the numbers would be 1 there. And that's why I said like minimum of sum of all the numbers would be greater than equal to 1. If we do the same arguments for columns as well, we would get minimum sum of values of all the columns will also be 1. And that's how I came up with f of k must be greater than equal to 2. And then I said like if we fill it in this order, 1, first this cell when k is 1, then these two cells when k is 2, 3, then these two cells when k is 5, these two cells when k is 7, this and this cell when k is 9. If you keep filling it like this, you will always get that only one of the rows will have odd number of ones, all the other rows will have even number of ones. And that is how you can able to get like f of k equal to 2 here, not 1, 2 here. And that was my argument. Like that's how I came up with like for odd values of k, f of k would be 2. And now when I said like k is the multiple of 4, we can always fill it in the blocks of 4 like this. And so on. So in this case, like f value would be 0, because all the rows will have like Xor 0, because every row will have even number of ones. So like these are the 3 simple cases. Probably a lot of people would have figured out, but you would have still got a WS. Like with just this observation, like I was getting WS. And the lot of people what other people did was, whenever k is even but a multiple of not a multiple of 4, they assume that f of k is 2 here. And like that's how they came up with the formula like 3n into m, something like that. 3n into m by 2, something like that. They were able to get the formula, and like that was giving you a WA here. And the next observation was f of 2 is definitely 2, because like anyway you fill, like if you fill two cells like this, then like XOR for this row would be 0, but XOR for these rows would be 1 and 1. Or if you fill it something like this, then also that holds. And if you fill it something like this, then your value of f would become 4. And the next idea was like a lot of people assume like f of 6 is 2, and that is a wrong answer. Like I will give you one example where f of 6 becomes 0. 1 1 1 0 1 1. Here like f of 6 is 0. If you look this row, there are two ones, XOR is 0. If you look this, there are two ones, XOR is 0. If you look this, there are two ones, XOR is 0. If you look this, there are two ones, XOR is 0. If you look this, there are two ones, XOR is 0. If you look this, there are two ones, XOR is 0. And like that is the critical piece here. And like now if you want 10, like you can just place two ones, 4, like you can add blocks of 4 again and again. Like you have got 6 ones in 9 cross 9 blocks here. You can keep placing, like this would be the answer for 10. So like n and m are ones, like you can pad extra zeros here. And like you can keep going it like this over here. And like that is how like, and like the idea was like this, or like the thing you notice is that we at least need 3 columns here. So if n equal to 2 or m equal to 2, you cannot make anything like this, because n equal to 2 means you will always end up filling it like this. So in that case f of 6 is 2 again. In this case f of 10 would be 2 again. Like cross basically means I am putting 1 there and so on. So if n is greater than 2, m is greater than 2, then only f of 6 can be 0, and you can keep going it like this. And after some observation you will notice that it holds true only for k equal to 2 and k equal to n into m minus 2. F of k would be 2. For rest f of k would be 0. And like n equal to 2 or m equal to 2 is a special case where for every such number like XOR would be 0. And like that is the solution here. Like once you notice this, first thing first, like I just printed like for n equal to 2 and m equal to 2, the answer will always be 6. This is the sample. Then like each type the number of such values would be 0. So let's add 2 into 2 for k equal to like this is the count of numbers where like Xor is k is odd. This I have added answer for odd k. If minimum of n and m is 2, then for all the even numbers which are not the multiples of 4, like the value would be 2. Otherwise, we only need value 2 for k equal to 2 and k equal to n into m minus 2. And print whatever value you have got so far. The question is like, I struggled a lot with finding this observation. So what I did was, yeah, like I ended up brute forcing. The idea was to use like bitmask DP kind of a loop. Like I brute force for 4 into 6 matrix, which is around 21 cells. So the idea is plus 4 is for k equal to 2 and k equal to n into m minus 2. The idea is like there are total n into m cells. Each cell can have a 1 or a 0. So total number of possible combination would be 2 to the power n into m. And you can probably use recursive solution as well, or iterative solution, however you want. What I did was I tried all the possible combinations here, which can be 0 or 1. The idea was to use a mask of length 0, mask from 0 to 2 to the power n into m minus 1. And if jth bit is, or like we can also have one order of this number is 1, then like if this is how my matrix looks like, then I find jth number in this order and make it 1, and so on. And the idea was like after brute forcing this, look at what are the possible answers you can get for each numbers. For all the possible masks, and like this would be the number which I would make 1. Like instead of using two different vectors for row and column, I ended up using single vector. First m minus 1s are for the columns and last n are for the rows. Take sum of all of them. Take and also keep a count of how many numbers are there. So result of that k, take it with whatever minimum value you have got. First I brute force it for 4 into 6 matrix. like 2 to the power 24 will take some amount of time. I found was like, wait 1 second. Okay, not J. M plus rho it should be. So what I found was like the answer is 0 for 4, 6, 8, 10, everything except like 22 and 2. For all the other even numbers, answer was 2. Then I just check like whenever like k is 6 and value is 0, print all the values which I am getting here. And this ended up printing the pattern which I showed you. And like then once I found this pattern, like the problem was relatively easy, I would say. So any questions on some of those before we move to the next problem? Those. It says MR has given you an array A of size n and an integer x. Let f of L comma R denote number of pairs I comma j such that L is I and j are between L to R and AI plus AJ has exactly x digits. Your task is to calculate this value for all the numbers. So basically what it says is you have an array AL, AR, AL. You take a subarray this and count number of pairs in this subarray such that AI plus AJ equal to as x digits. Another way to see this is like x digit means the number is between 10 to the power x minus 1 and is less than 10 to the power x. Because smallest number with x digit would be like 1 is the small, 0 is the, let's forget 0. 1 is the smallest number which has 1 digit. 10 is the smallest number which has 2 digit. 100 is the smallest number which has 3 digits. 1000 is the smallest number which has 4 digits and so on. So like we can, let's say we have a solve function a comma some m is given to you. It will count number of pairs where AI plus AJ is greater than equal to m for all the subarrays. Then you know like we can call this method 2 times. One when the value is greater than 10 to the power x minus 1 and then subtract how many times the value is more than x digits. This is the first idea we have. Any question so far? Like how I am changing it to from exactly x digit to count the number of pairs which have sum greater than equal to something which I have already known. Okay, now let's look further. Instead of counting for each subarray, how many pairs are there? Let's do the reverse part. For each pair, count how many arrays it is a part of. So for example, if you have AI, AJ, such that AI plus AJ is greater than equal to M, for which we want to solve. Then you notice, if you choose any left point endpoint from here and any right endpoint from here, you will get Aij as one of the pair inside it. So for each pair, we can multiply it with L into R n minus R plus 1. Basically, how many left borders we can choose such that border is less than equal to R, and how many right borders we can choose such that the value is greater than equal to R. Like if you choose any L from this border and any R from this border, this would be one such pair. So I am doing reverse. Instead of counting for each subarray number of pairs, what I will do is for each pair count number of subarrays it is a part of and take that as a sum and print it, and it should give me the same answer. Any questions on that? Okay, now I did something more. I have this AI and AJ. What I said was, like, let's look for every pair where AI plus AJ is greater than equal to some M given to us in the solve function. So like if you choose any left border which is less than equal to I and any right border which is greater than equal to J, Aij would be a part of that pair. So instead of counting F for each subarray, how many numbers are there with sum greater than equal to M? Let's do the reverse. For each pair where the sum is greater than equal to M, count the number of arrays it is a part of. Like these are two ways to look at the same picture. Like let's forget instead of pair, like we have a simple array where some elements are 0, 1, 0, 0, 1, 1, etc. If we define f of L comma R as number of ones in that array, and if we want sum for or L to R, what we can do is like we can look at it other way. For each one, count how many arrays it is a part of, and so on. That was the main intuition for this problem. So the idea is like if a number is on left side, we can see that it contributes I there. And if the number is j, it contributes n minus j plus 1. Right? What I will do is I will fix some aj, and for every number before it, for all the index like a, I1, A, I2, etc. would be there. A, I3, etc. Such that, like, if this number is greater than equal, if this number is greater than equal to m minus aj, then sum with this number would definitely be greater than m. For this number should also be greater than m minus aj. This number should definitely be greater than m minus aj, and so on. So in this part, for all the numbers which are greater than equal to m minus aj, find sum of I over there. Like, instead of counting it for each pair, I am counting it in one go. When I have fixed a particular j, look at all the possible i's and count all the values there. Like, if I do it like this, I would again get the same answer, right? Because for each I, the left side would definitely be I. And like, this sum should be multiplied by n minus j plus 1, of course, for the final answer. That was the part. Any question on this? Like, for all the I such that ai is greater than equal to m minus aj. Count the sum of I for them and then multiply it by n minus j plus 1. And if you keep doing it for all j, you will get the total answer. So, like, you first check what are the possible combinations you get when your aj is equal to a2. Then you check what are all the possible pairs and arrays you can get when your aj is equal to a3, aj equal to a4, so on up to an. So the idea is, like, now your problem is reduced to, you have some segment. Let's say this is called, like, sum of all the index where value is ai is greater than equal to some given value you have. And this part can be, yeah, I think, like, there are a lot of homework problem. Rather than going into the final detail, I will rather give you some homework and some things to read. One way is Fenwick tree plus coordinate compression. Fenwick or segment tree. Or segment tree plus coordinate compression. Or there is something known as dynamic segment tree as well. Like, probably I don't have writing here, but there are two things that you can probably read, and a lot of problems are there to solve this same problem. Yes, we definitely need a lower bound as well. So, like, USAV guide is something which I recommend people to check out whenever they are looking for resources. And CSES is also there. Or probably CP algorithms. Okay, CP algorithm does not have anything. Okay, 1 second. So, like, there are a lot of like, Probably let me search. So like this is one problem which you can try out, or probably one second. Array. Okay, probably I will end up explaining this rather than trying to search problem for this. Where is my pen? Yeah. So the idea is what I will do is like I can first take all the given numbers a1 up to an. I can put them in a map, and then for each value in map, like I can keep increasing them. Like basically for smallest number, like I use a normal segment tree or Fenwick tree, but like smallest number I put it at index 1, second smallest number I put it at index 2, third smallest number I put it at index 3, and so on. And then like whenever like I can use a lower bound to find the smallest index such that BL is greater than equal to whatever given value I have. And then I can take Fenwick tree sum for that one. The problem was LENGTHX. Like this is a quickest way to do it. You can probably use it in the map. What this method does is it sorts all the given numbers, and then it removes all the consecutive equal numbers. Now B0 is smallest number, B1 is second smallest number, and keep go on. So I will show you an example. One, two, three, four, 5, 6, 7, 8, 9. So after like this snippet, like this sorts all the numbers, and unique method removes all the numbers which are equal to each other and gives us the last pointer. So this essentially ended up removing all the consecutive numbers which are equal. Okay, I ended up using like int 128 to just in case avoid overflows because of the way I was dealing with. Okay, I have to also specify X here, right? I hope it compiles. Yeah. So this is how my vector becomes. The smallest number here is 1. Second smallest is 2. Third smallest is 3. All the multiple occurrence has been removed, 5, 10 and 12. That was the idea. Now I can create a finite tree of size of b, because that is the count of distinct numbers I have. And like what I did was, what is the minimum sum I want? What is the maximum sum minus 1 I want? Because all the x digit numbers would be between low and high, where high is not included. So if current number is greater than high, ignore it. Otherwise, I find the smallest index where the current number is whatever sum I require minus 1. And R is the smallest index where like my current sum with current number becomes greater than equal to whatever high I need. So I take, using finite tree, I take the sum of all the indexes which are between L to R, multiply it with n minus 1, it's zero based indexing. And then for find the index in B where the current number exists. For that value, add like the current index count. Or you can probably call it a zero based indexing. And essentially this was the solution I had. Any questions on this one before we move to probably the last problem for today? Yeah, the cards machine would be my last problem for today. Yeah, like probably finite tree and segment tree is something you should read out for. Like there are many videos, tutorials for it, just Google it. And like I remember segment tree was the first data structure I learned when I tried to solve it. So like just search for segment tree, finite tree, anything works here. And the main idea is like I will give you one sample problem to solve. You have given array A. You have some updates where you can change some index, and then you have also values from L to R, which should be, you have to find the sum of values. Like you have two types of query. Given one index and one value, update that index with the new value. Given two values from L to R, find the sum of values from L to R. This is something you can do it using a segment tree. Range some query or something would be the name for it. And because the values here were up to 1 to 1e9, we have to also add a coordinate compression layer for it. Okay, problem statement says you have a deck of n cards and a cards machine. The ith card from the top has AI written on it. You and your opponent will play a game with the following step. Your opponent removes some, possibly 0, but not all cards from the top of deck. Your opponent removes some, possibly 0, but not all cards from the bottom of the deck. By top and bottom is a bit confusing. Let's call it like we have an array A. You can remove some numbers from starting. You can remove some numbers from the ending. And whatever number remains, you take the maximum two numbers from it. If both of those numbers are equal, you win. Otherwise, your opponent wins. So like you have been presented with an array, some array. You remove some numbers from starting, you remove some numbers from ending. You look at maximum two numbers in the remaining part. And if both of them are equal, you win. Otherwise, the opponent wins. First thing first, for some given array A, it asks us to count how many pairs we can count here. Like we have array A1, A2, some L, some R, and then AM. It says for how many such vectors? Maximum from AL to AR is equal to second maximum in the same range, AL to AR. Like my idea is again similar. What I will do is, for each index j, like I can fix a particular number j and count how many pairs it is. Like if I fix a particular value of AR, then you see like as I move on this side, my max and second max increases. Keeps increasing. Like there is something known as monotonic stack, or preferably what I did was, like our array would like this, look like this. First, like if I fix a particular value of r, my idea is I will iterate from all r equal to 1 to n and count how many possible left are there. Basically count number of ways I can remove some prefix and still win. First thing first, if I compute that for each value of r, we fix r, find all the L such that L to R has maximum number at least twice. For this to happen, maximum should be suffix max from r, and previous getter should be less than previous occurrence of max. Something like that only. Like definitely the solution I coded was more difficult over here. So like I count like from where this AR exists. Let's say this is the other place where AR exists, and this can be the next maximum we have. Like if I look at like all the places where maximum keeps increasing, then it would be look more like, probably let me take one example here. 3, 2, 1, 3, 2, 1, 6, 4, 5, 2, 6, 9, 9, and so on. If this is my array, and if I do not remove anything from here, like this would be the first valid array. You can also include this here. You can also include this here. But once you include 6, maximum becomes 6 and it appears only once. So the next time you will get a valid array would be this. When you include 9, array becomes wrong. Next time the valid array would be like this. Like taking everything would be a valid array. So like we can maintain like where all the maximums come in a monotonic stack. Like the index of these maximums 3, 6, 9, etc. can be maintained using monotonic stack. Along with that, whenever we are pushing new element in the stack, we look at previous occurrence where it occurs, and if that occurrence is before that array, then we can actually add this in our count here. And like that was the idea I had. Like for 6, like the monotonic, like this is the next time it appears, and the next number after that would be 9. So like there would is one possible answer here. There are 3 possible answers here, and like I tried to maintain the index L to R and kept counting it to get the answer for a fixed R. And then if we know for each R the number of L's, for which the array is valid. Then to find the complete answer, for the complete array, the answer would be sum of all the L count R you have. And to solve it for the second part where we have deleted some numbers from the end, if you have deleted some numbers from the end, you just need like the sum of all the count L for the remaining elements you have. And like that was essentially the solution I have. Like a lot of implementation would be involved, how you maintain that monotonic stack over here and how you keep updating the count of valid L's there. I can briefly show my implementation, but yeah, 1 second. Error. The cards. This is valid L count, valid L range, and like previous time when a particular number has occurred. I take the current number. As long as current value at the top of stack is less than equal to R, remove all the ranges for that particular number which were valid for that number, and keep removing that number from the top of stack. If this number also exists before, find the place where this number exists, and what is the last index on the top of stack. If stack is empty, you can take 0. Otherwise, you take like what is the other maximum number you have, that index plus 1. And everything from L to R here would be valid with current as max. So if this is between L to R, for valid range of current, I add value from L to R there. And I also add like the count of that numbers as a sum here. And I add like probably, let's not call it answer. Let's call it valid L count. So valid L count for this current index would be and the idea is like if you take a prefix sum for this, you can get the answer for each range. For each prefix, like now you have already pre-calculated the answer for deleting each k. If you delete everything, the answer is definitely 0. If you don't delete everything, then what is the answer if you delete the last k minus 1 element? So like the sum, it would be sum of all the valid L counts for the first n minus k minus 1 numbers. And that was the solution I had. Any questions on this problem or any other problem or something that I should try to explain it, or any other questions you guys have? I would be happy to answer them. Otherwise, I will call it a day today and probably end this stream. So thanks everyone for joining today. Okay, what about the last problem? Like I had some idea for this problem, but my solution was definitely giving wrong answer for it. Yeah, like I was also trying to do sort in the decreasing order, and like I also did one more DD there, but I was always getting WA there. To brief about like my idea was like there are two cases there. I may have missed more cases, I don't know, but my idea was one thing is like let's pick all the non-native people and put them in a circle in the increasing order. This is a circle here. And the idea is for this is a circle here. One idea is for every number, insert the numbers here. Find the largest pair between which you can insert a number, insert all the equal numbers there. And the next thing is like, let's say you have a number with frequency 5. Keep inserting in the decreasing order. And here you have inserted 3 equal numbers. And you cannot insert a new number here. So the idea is find the one with the least frequency here. Remove the least frequency number from here and insert the new 5 numbers you have here. And you can keep doing this. That was one case I had. Another case I had was so like in this case, like this is a valid example we have. So like 1, 2, 3, 10, 12, 100. Here you can insert 99 two times. Here you can insert 11 two times. Let's say this is 9 here. Now if you have 10 times, you can probably insert any one number and remove that number and insert 10 3 times here. That was the first idea I had. The other idea was like always keep some suffix there, and like one counter test case I see here is like instead of this number here, you can also insert 11 here. So like the place where you have inserted all the non-rated smaller number, you can use that place to insert one of the rated number there as well. Like these are the two cases I had, and I definitely got WA there. So I don't know why this works, not works. Probably I think the editorial should be out, and you can probably look at the editorial there. So in this case, like you have all the equal number of segments where you have all the count of non-rated people. And another case was between two non-rated people, you insert all the non-rated people, and that was like I did not even got 2 WA there. Yeah, like link YouTube flags it. Like if you post a link in a YouTube comment or a chat, YouTube just removes that. Because YouTube thinks like people just spam it using the links. You have already seen what happens when like a lot of people put spam links on Discord as well. So any other question anyone else has before we call it a day today? Like probably it's not of this contest. You can probably post it on Discord server, and I hope someone will take a look at it, not just me. Yeah, like if you are posting a link, you may see it there, but definitely I cannot see any link here. Like this is the chat I see, and YouTube has automatically removed all the links. Okay, there are some other questions like how to learn DP, etc. So like this is the most, I think I don't have a Discord server here. Like I am not logged into my Discord server right now, but the idea is like you can probably join my Discord server. There is a channel known as Roadmap to Red in the Discord server, and there I have answered like how to learn topic X, like what are the resources you can learn there. Like I am not logged into Discord right now, but if you join the Discord server, there is a channel known as Roadmap to Red there, and there I have answered a lot of questions like how to practice some topic X, what I did when I was rated like expert, I was candidate master, etc. And like I also said some common resources which you can find to learn, search anything for DP or gritty or any other topic. The most common resources which I share are USAV guide. This guide is divided into 4 sections: bronze, silver, gold, platinum. Bronze is the easiest division, and platinum is the hardest division. And like bronze is equivalent to div 4 there, and platinum is equivalent to div 1 or harder there. So based on your rating, you can pick the division and you can keep doing that part. CP algorithms is one. CP handbook, there is something known as CP handbook as well. And like you can also read this, like there are around 300 pages here. And like this handbook, it should also always be complemented with CSES problems. Yeah, like probably one question is, sir, how to be specialist in this cheating era? Like, unfortunately, I don't have a solution for this. Like, the only thing I would say is like, keep grinding. Like, the day when you jump, like, you will definitely have a lot higher rating than just specialist. Because like the time for the duration for which you will remain specialist would be much less compared to most of the people, which people used to have in the older era, I would say. Like it's an unfortunate situation that a lot of people cheat. What they don't really understand is like rating does not help them, rather the skill which you have acquired while solving problem will. Because like I don't remember like my rating was useful at any point of time when I was searching for companies. Rather the tests they used to take, interview questions they used to ask, and how I used to answer them was the critical parameter. Like there is no wild card even if you have a 7-star rating, not just 5-star. And by the way, there is one more thing which I forgot to mention. There is something known as a catalog on Code Forces as well. So like you can probably try out that idea. It also has a lot of useful articles there. And like the only way to improve at combinatorics number theory is like solve problems related to them and try to solve them there. Like you can search out for like standard problems, you will probably find here CSES. Like, this is definitely not exhaustive, but something from which you can start. Like, this is dynamic meaning query, range update query, etc. The problem segment if and problem I was mentioning before. Here the values are between 1 to n. So you use coordinate compression to do the remaining bit. So like you can probably take these two as a homework problem to solve out for the segment tree. Minimum won't work with Fenwick tree, but yeah. Like the very first resource I would suggest is to solve problems. And whenever you are stuck in a problem, you can Google for the resources. Like for example, yesterday's problem says we can for you, so like you should start with like the bronze division. Bronze is the easiest one. Difficulty is due 4, and platinum is harder than due 1. So like for example, in yesterday's contest, you would have found that it says you should use try somewhere. Xor data structure called try. And now when you are absolving it, that is the time when you should learn what try is, how to implement try, solve some problems on try. What is difference between absolving and solving here? Absolve means there is a contest in which you participate. Let's say you have solved 2 problems there. Now, as a homework, you try to solve problem number 3 and 4. While solve is like you just found a seat somewhere or something and you try to solve problems there. Absolve, for absolve problems, like those are the problems you would have seen in a contest a day before when you are trying to solve. While absolve is you may not have seen that problem before. That's the only difference between absolve and solve. And the reason why I focus on absolve is because you spend some amount of time trying to solve those problems because you don't have any editorial or anything. Like you are forced to think for those problems for around 2 hours or so, and then you solve it. And often rating is the motivation, and you don't really know the difficulty of a problem before you solve when you are participating in a contest. So like a lot of time people get biased by looking at number of AC submission a problem has. If they see like a problem has only 100 submission, they don't even try. But when they see a problem has 2000 submission, they try it. So if you look at my stream, most of the time I don't even look at the number of problems someone has solved or what is my current rank in the contest. Because if that is too low, I stop thinking about thinking that this problem would be hard for me. And when that problem gets a lot of AC, even when I solve that problem, my rating is relatively worse when it would have been had I not seen the number of AC or my rank at that point of time. But yeah, how to optimize greedy to DPS, sometimes it becomes more complicated. The way I see is like I try to solve problem using DP, like because DP is something to me looks like I can prove it. And then there is something known as exchange arguments. There is a lecture by Erecto on exchange argument. And there is one algorithms live lecture as well. You should read them. And like here there are techniques mentioned what you can use to make observations for the greedy and how you simplify a problem. So like this is something you should definitely read for. Like it will give you some indication like when a particular greedy should work or what like when like why you should why I thought of taking all the numbers in the prefix. And that is because exchange argument, like if you remove one of the numbers from prefix, your OR will definitely increase if you add more number, but it would be less than some particular number there. Yeah, like that is fine. Like generally, I don't rely on problem rating. Rather, I try to solve one or two more problem, whatever be the difficulty generally. Because rating to me does not looks like it's always perfect. Like, and generally it makes no sense. Like if you ask, I am solving 2400 problem. If the problem is 2500, I will not solve it because there are some strong areas where I am good at. If the problem is from that topic, I will probably end up solving 2700 problem. But if the problem is for my weak area, like it can happen that I cannot solve the problem with rating of my current rating as well. Yeah, like over time, definitely, like if you pick a particular problem in the old times, rating would definitely be higher than the current time. Okay, how you used to balance college and coding? Probably something I did. I won't recommend others yet. Like in my college, like there was no attendance criteria, so I just used to stay at my hostel most of the time. And like there used to be long challenges back then. Like I think I have also answered this question on my Discord server. And these contests used to last for 10 days. So I used to have some problems for which I cannot know the solution for the next 10 days. So I used to keep thinking about those problems for 10 days and keep learning new data things while trying to solve those problems. And that was the way I improved. Yeah, like 75%, like one shortcut you can try to do is like try to solve problem in the class sitting on the last bench. If you feel like what a professor is teaching, yeah. Yeah, like again the same problem. Why like for 10 days were way too large for people to get solutions from different places. Yeah, like I definitely believe compulsory attendance should not be there. Like these are not the school going kids where you force them to come to attend a class, grade, etc. Like you can definitely punish people for having low attendance by reducing the marks if you want. And like that is what some professors in our class used to do. Yeah, like I have no count of how many hours I used to do. Like it was mostly like whenever I had some time and like just used to do it. I'm not sure like if any problem with long contest exists. Like Hacker Earth also I think stopped organizing long contests. CodeChef has stopped organizing long contests. Like all the contests I see are of just few hours only. There is one marathon contest on Top Coder, but it is very different from competitive programming. So like that is the idea. Yeah, like it's definitely because like that was one factor why courts have stopped long contests. That's Sunraj, yeah. Like I would say just increasing the number of contests does not increases your rating because it can happen that you are solving way too easy problem. The more thing is like you should push try to solve harder problem. And like after the end of like if you look at last 15 days, it should be that you should learn something new or you should have a feeling that I am definitely improving because rating may not be a good measure, but trying to solve a relatively harder problem, like basically coming out of your comfort zone, is how you keep increasing your rating. So like Fang interview, like I have not given interview at any Fang company yet. So like one question which a lot of people ask is like they have some placement in let's say 6 months or something. What should they do? For them, my recommendation is to start lead code like there are some top 100 interview questions. There is something known as NEET code 75. There is one Striver. Sheet, etc. Like you can keep targeting this one, and like probably I would say code forces is a bit overkill. Adcoder is something you should definitely try out. Like easier problems are helpful. Like F and G might be a bit higher, but yeah. Okay, how do you earn? Because I work from 9 to 5 job every day, Monday to Friday, not Saturday and Sunday, hopefully. Like the way I used to do was I used to have multiple problems about which I used to think. Let's say you have 10 problems you are trying to think. There would be one problem where you would get an observation, or if you are not making any progress on them. So look at hint for one, solve one, add one more problem in your set, and keep doing. When you have 10 problems, you can think about them in parallel. You can think about them at different places, whatever you are doing. And that is how over. Yeah, like your code quality, like the only way to improve code quality is to look at people who write better code. Like I believe Jing Lee writes better code, Tourist writes short code, and over time you will pick up the habits that they are doing. For example, if you look at my code, it always says like constant auto, and I use constant because that is one habit which I picked up while writing code in the industry. Like if you don't intend to change a variable, you should always use constant. Yeah, like probably profile review, I will leave it for some other time. Like if I am looking at like one thing I use is like the problem count looks fine based on the days, but generally I am more interested in like this rating distribution of the problems you have solved. For this, you can probably use TLE bot in the Discord server I have. Like I think I already answered DP. Like you can use USAV Guide to read some standard problems. You can use CP handbook, and like the only way to good at DP is to try to solve a lot of DP problems. Yeah, like I think probably I will end up hosting some session where I would be reviewing different people's profile, because probably for today I would like to end the stream. Like I think it's around half an hour I started answering the questions. But yeah. And yeah, good night everyone, and thanks everyone for joining today. And like for fan victory, like just pick any one of them and start reading them. If you don't find best, you can look at the second one. Like a lot of people have created a lot of things, but at the end of the day, everything is just the same. Like there is exact same algorithm which everyone is teaching over.